Hello everyone, my name is Christian Bowen. I'm a sophomore meteorology and atmospheric science student at Penn State University. So today, there is a moderate risk in place for a large portion of northeastern Oklahoma and along the south-central Kansas border that includes cities such as Tulsa, Oklahoma, and along the Kansas border. Here's a 500 millibar height in decameters and wind in knots where you have winds up in excess of 65 to 70 knots here along the Kansas and Oklahoma border, and later in the day that will increase as you head towards night and move along to portions of northeastern Oklahoma, pushing cities like Tulsa, Oklahoma. Here is the low level jet. This is also a 21Z, which is around 4 o'clock Central Standard Time. And you can see here in northeastern Oklahoma, wherever these storms are going to be initiating in Kansas, moving southeast into across the Oklahoma and Kansas border into northeast Oklahoma. The lower level jet here is cranking, and once it crosses into northeast Oklahoma, that is when it will become most dangerous, in my opinion. This is the 2-meter dew point temperature in degrees Fahrenheit, and right here I have circled right where the Storm Prediction Center has the moderate risk, and you see here whenever you have upper 60s and mid 60 dew points along the Oklahoma and Kansas border, that is when you have extreme tornado potential. And right here, wherever it's 67 degrees Fahrenheit, I think this area along here and closer to Tulsa is the greatest risk. Whenever you have little notch here in the plains, I always look for tornado potential with that notch. Here you have the hodograph and the skew-T diagram. In the hodograph, you have grade 0 to 3 kilometer shear and mostly streamwise vorticity in 0 to 3 kilometers. But above 3 kilometers, it's really messy. All the from 4, 5, 6, 7 through 12 kilometers are all bunched up there, which I do not like. If they become less bunched up and have better streamwise vorticity, then the chances of tornado potential will even increase, which it's already really big. You have the LCL just above 850 millibars, and you have CAPE in excess of 2,800 joules per kilogram, which is really good from the surface. And the most unstable CAPE is also where the surface CAPE is the greatest, and that means these storms are going to be surface-based, which is great for tornado potential. Here you have the GFS Energy Helicity Index from 0 to 3 kilometers, which, remember from the hodograph, there was large 0 to 3 kilometer shear right in this area where I pulled the hodograph from. And the Energy Helicity Index is around 4.7 to 5 along the Kansas and Oklahoma border. And it will move farther southeast into northeast Oklahoma and the Tulsa, Oklahoma area as it progresses. Here is the HRRR model with composite reflectivity. You can see how there is embedded line of supercells with this line here, and these will move southeast towards the Tulsa metro area. And what you need to know about the HRRR model is that it overdoes stuff, so the storm system will not look as bad as what it is right now, but it gives you the sense of what could potentially happen. If this happens, all heck could break loose, and there could be dangerous long-lived tornadoes on the ground, which would be very bad for the Kansas border and into northeast Oklahoma, including Tulsa Metro. Here's the Storm Prediction Center's Day 1 Tornado Outlook issued at 12:41Z today. And you have the 15% hatched risk in the Kansas and Oklahoma border along the I-35 corridor heading towards Oklahoma City. But you have the 10% hatch risk that includes the Oklahoma City Metro and the Tulsa Metro in Oklahoma. If you're in these zones, including the 5% and 2% tornado risk, please know your action plan for tornadoes. If a tornado warning is issued, please go to the most interior room possible at the lowest level, and if you have a storm cellar, that would be the best possible area. This today has the potential to be a very large severe weather outbreak that incorporates long-lived tornadoes.